Hello there and then welcome to a brand new video. This is Hub Beyond Numbers, where we learn maths the easy way. Now in this lesson we are looking at significant figures. As you can see here, we are looking at significant figures. When we say significant figures, what at all is it? You realize that it is mostly used in scientific calculations. So when we say significant figures, we simply means the digits in a number that carry meaning. Alright, so let me write that down. We say the digits in a number that carry what meaning. So as you can see here, significant figures are often written as SF. You see, so they are digits in a number that carry meaning about its accuracy or precision. So let's say we all want to measure, let me say, a bag of rice. Now, as you measured, you realize that it was 5 kilograms, right? But someone else comes and then use a more sophisticated instrument, and then the person has 5.02 kilogram. You realize that this one here or this number here gives us more accuracy. It gives us a detail about how accurate our weight measurement is, unlike this. You see, so significant figures gives us what the meaning about the accuracy of a digit. So on that note, if we have a number such as, let's say, 24.6, this one is actually made up of what? Three significant figures. You see, on the other hand, if we have 0.00340, this is also made up of three significant figures. Now you might be asking, why does this have significant figures of 3 and then this also have significant figures of 3? That is our next item we'll be looking at. So ways we can identify what or count significant figures. To do this, there are some rules we need to follow, and I'll take you through these rules with adequate examples. So let's look into the rules. So talking about the rules, the first rule we'll be considering is what you have over here. And it says all non-zero digits are significant. All non-zero digits are significant. So as an example, if we have the number, let me say 143, you are being asked how many significant figures you have here. If you look at it carefully, we have 1, 2, 3 digits. Is this one significant? Yes, it is, because it is a non-zero digit. If we say non-zero digit, we simply mean all the numbers from 1 to 9 inclusive. So 1 is a non-zero digit, hence it is significant. 4 is also a non-zero digit, hence it is significant, and same applies to 3. So this we have here has got what? 3 significant figures written as 3SF. You see, it doesn't only apply to whole numbers, but it can also apply to decimals as well. So that if I have 4, 8, so that is 48.5. This here has also got 3 significant figures, because this is a non-zero digit, this is a non-zero digit, and then this also is a non-zero digit. And hence we can conclude that it has 3 significant figures. Now, what if we have a number that has 0 in it? For instance, instead of our 143, we actually have 103. You see, so that takes us to our next rule. Okay, and our next rule says that zeros between non-zero digits are significant. Zeros between non-zero digits, they are what? Significant. What does this mean? Let's look at some examples. It is important you take note of the rules, because without the rules, you cannot determine them. Hence, as I wrote earlier on, if we have 1, 0, 3, how many significant figures do we have over here? First of all, we know that this rule that says all non-zero digits are significant. Hence, this is significant, and same applies to the 3 over here. But what of the 0? So that is where this second rule comes in, which says zeros between non-zero digit. So this zero here, it is between this non-zero digit and then this as well. So that makes it also significant. You see, hence we can conclude that this number we've got over here has also got three significant figures. You see, the same applies to 2000 and then 3. How many significant figures does it have? This is significant. This is also significant. And these are zeros in between significant figures. So they've also been infected with significance. We can therefore say 1, 2, 3, 4 are all significant, and hence we have 4 significant figures. The last one we'll be looking at 1.005. How many significant figures has this also got? So we know that this is a non-zero digit, which is significant. This is a non-zero digit, which is also significant. And we've got these in between. They are zeros. And so far as they come between significant figures, we can also say they are significant. Hence, we have 1, 2, 3, 4. So this has also got 4 significant figures. Now, what if we have what we call leading zeros? By leading zeros, I mean if we have a number such as a 0.143. This zero here isn't between any significant figure. So how do we consider it? That takes us to rule number 3. Rule number 3. So rule number 3, as you see on your screen, says leading zeros are not significant. You see, so that is leading zeros before the first non-zero digit. They are all not significant, right? Hence, if we have a number as what I wrote here, that is our 0.143. This is a leading zero. You see, and it comes before the first significant or non-zero digit. Hence, this here is not significant. You see, and we can still conclude that this has got just 3 significant figures because this zero here is a leading zero. It leads the number. The same way, if we have 0.0045, you see, all these zeros here, you see, they come after the first non-zero digit. Hence, they are not significant. Take note. They are not what? Significant. Therefore, we can conclude that this number has got just 2 significant figures. You see, that is why it doesn't matter the number of zeros. So far as they all come before our significant figures, they are all not significant. You see, so this has also got just 2 significant figures. That is the reason why in mentioning numbers, if you write 01, 02, 03, 04, we write all these as placeholders. You see, we call all these zeros placeholders, but in actual sense, they don't affect the value of these numbers. This 01 is still 1, this 02 is still 2, this 03 is still 3, this 03 is still, sorry, the 04 is still 4. Is it because they are all not significant? And you should take note that it is not all significant, it is not all non-significant figures that can be omitted. What do I mean by that? For these decimals we have over here, even though these zeros are not significant, we have to write them. If you choose to omit and then you just write the 45, you have changed the value of the digit or of the number, you see. So even though they are not significant, we cannot omit them. On the other hand, for whole numbers, as you can see, we have said these are not significant, you see. And if you omit them here, they don't change the value, they still remain the same. So for leading zeros that appear before decimals, we cannot omit them. But for those that appear as whole numbers, we can omit them. All right. So that is that. So since we have looked at leading zeros, what of trailing zeros? That is zeros that end. Do we say they are significant or not? Let's look at that. Now, talking of trailing zeros, there are two types. So there are trailing zeros in a decimal, and then there are those in whole numbers. So we'll start off with those in decimals, right? Now, the rule that applies to them says that trailing zeros in a decimal are significant. Take note, if we start with a whole number, you would see the otherwise. What do we mean by trailing zeros in a decimal is significant? So if we take 2.30, this here is a trailing zero. It is a trailing zero. Trailing means it is the ending zero, right? And it is telling us that it is significant. Unlike leading zeros that are not significant in decimals, trailing zeros are actually significant, you see. And you would have to take note of this rule because it would really be needed when we want to write certain digits in decimals to a specified significant figure, you see. So trailing zeros in decimals are actually significant. Hence, for this, we have what? Three significant figures because this is 1, 2, and 3. This zero is significant. On the other hand, if we write 2.3, this one here has just got two significant figures. Now, in mathematics, you realize that both of these are of the same value. Both numbers here are of the same value, but they are of different significant figures. This one has got 3, that is plus the trailing zero, and this has got 2. If we have 0.04500, these zeros here, we have 1, 2. They are what? Leading zeros. And we know leading zeros are not significant. So these are out. They are not significant, but we can't omit them. Non-zero digits are significant. So we have 1. Non-zero digits significant. So 2. And then these here are now trailing zeros. And they come after a decimal. So they are at the decimal side. Hence, it is significant. And then this is also significant. Hence, we can say that this number here has actually got 4 significant figures. 4. The reason being that these zeros here are trailing zeros. And we said trailing zeros in a decimal number are significant. You see? Okay. Now, on the other hand, what if we come or we have numbers that are not decimals, but they're actually whole numbers? Whole numbers. Are their trailing zeros significant? Let's look at the rule that applies to that. So looking at this last and very important rule, it says trailing zeros in a whole number without a decimal point are not significant. Take note, trailing zeros in a whole number without a decimal point are not significant. And what does this mean? So if you have 1,500, for instance, and we want to count how many significant figures we have in here, it is actually just 2. 2 because these are trailing what? They are trailing zeros in a whole number. And we know for non-zero they get from rule 1 that they are all significant, right? But because these are trailing zeros, they are not significant. But though they are not significant, we cannot omit them. Because if I'm to write this without these 2 zeros, it becomes 15 and not 1,500. So we say that though they are not significant, we do not omit them. Hence, this number here has got just 2 significant figures. Right? That is how it is. So if you have 49800 this year, how many significant figures has it got? 1, 2, 3. It ain't here, right? Because these two zeros are trailing zeros. And the rule says trailing zero in a whole number without a decimal point, they are not significant. Hence, we have just 3 significant figures. So these are the rules governing significant figures. In the next lesson, we'll be looking at how to round off numbers to a specified significant figure. And without much ado, I'll just give some exercises you can try on your own just to test your understanding. So these are the numbers we have over here. It says count the significant figures. I'll do the first one. So you also do this 1, 2, 3, 4, right? So for the first one, how many significant figures do we have? I know this is what a leading zero. So 1, 2, 3, they are all leading zeros. And we know leading zeros are not significant, but this is a non-zero digit. This is also a non-zero digit, and here we have is also another non-zero digit. There are 3. Hence, I would rather say that there are just 3 significant figures, right? So that is it for this lesson. If you found it useful, you can like or leave a comment. And if there's any issue of concern, you can always let me know at the comment section as well. If you've not subscribed and you want to receive notifications on upcoming videos, you can always choose to subscribe if you so do wish. And I'll see you in our next lesson where we look at how to round numbers to a specified number of significant figures. Bye for now and stay blessed.